Okay, this is an estimate for columns. So we have 4 columns here, C1, C2, C3, and C4. And these are coming from the tally that we have taken from the foundation plan. As you can see, we have pinpointed already all the columns. We have C1. C1, we have 1, 2, 3, 4, 5, 6, 7, 8. C2, we have 4. C3, we have 3. And C4, we have 21. If you look at the column schedule, C1 and C2 are both coming from the foundation up to the roof beam. C3 is from foundation up to the second floor only. And C4 is again coming from the footing or foundation up to the second floor level only. Okay, and then we have here one planted column. We will count this one later. So we have tallied the quantities: 8 pieces of C1, 4 pieces of C2, 3 pieces of C3, and 21 pieces of C4. So for the X and Y dimension, it will be the width and the breadth of the column. So we have here the dimension 200 by 400. So this will be 0.2 by 0.4. For C2, again, this is 0.2 by 0.4. By 0.4. For C3, (250 by 400). So this is the biggest, 0.25 by 0.4. And for C4, we have 250 by 250, 0.25 by 0.25. Then for the Z, this will now be the height of your column. So we can extract this height by looking at the architectural plan and looking at the elevation view. So in here, you will see the height from the finished floor line up to the second floor level is 3.2. And the height from the second floor level up to the roof beam is 3. So that is already 6.2. And then we have a difference from the finished grade line to the finished floor line of 0.2. So that will be 6.4 all in all. And then we still have a sort of slope here in the natural grade line. So by just looking at it, we can see that there is a big difference between both sides of the building. But just to be safe, let us assume the deepest part. Okay? And the deepest part, by inspection, this is estimated to be around 1 meter. Okay? So we add 1 meter to the 6.4. However, if we look again in the column details or maybe in the footing details, we can see that the required depth of embedment is 1.2. So there is an embedment of 1.2 plus the allowance for the slope, which is 1 meter, plus the 6.4 superstructure height. Okay? So adding all of those things, we can have 1.2 plus 1 plus 6.4. So that will be a total of 8.6 for the height of C1. And C1 and C2 have the same height because they go from the foundation all the way up to the roof beam. For C3, it's only up to second floor. So we copy, and then instead of 6.4, now 1.2 plus 1 meter, instead of 6.4, let's place here 3.2, as well as for the C4. Copy and paste. So we now have the heights of these columns. For the total volume, it will be the length times width times height. Okay, and then copy, Control C, then paste to their proper locations. Okay, so we have the volume of each of the individual columns. Now let's multiply the volume of one column times the quantity of the columns to get the total volume. So we have this formula, and then we copy it down to the other columns. Alright, so we now have the volume of concrete. If we click all these volumes, we can have a sum of 16.96, meaning all the columns for this project has a total volume of 16.96 cubic meters. For the rebars, the description, normally for columns, we have first main bars or vertical bars, then secondary bars or column ties. For the main bars, looking at the plan, we can see that this is 16 mm. So we place here 16. And then for the column ties, we have two sets of 10 mm. So 10 mm. And since there are two sets, we enter another row here. So let's say column tie 1 and then column tie 2. Okay, and this is still 10 mm. For the weight per linear meter, let's look at our table. For the 10 mm, we have the weight in terms of kilogram per meter, that will be 0.617. And for the 16 mm, 1.578. So 1.578 for the 16 and 0.617 for the 10 mm. For the number of pieces, for C1, we have 6 pieces. 6 pieces. For the column ties, let's keep this one first, and let's focus first on the length of each of the tie. For the main bars, we have the total length is just the length of the column or the height of the column. Then maybe you add hook. No, let's say the hook is 0.3. So that will be 8.9. And the weight now is the weight per linear meter times the number of pieces times the length of one cut. So that will be 84.27. For the total weight, that will be the weight of one column multiplied by the quantity. Okay, so we have 674.12. For the formworks, there are 4 phases. The first phase is the width, which is 0.2, and then we multiply it by 2. And the second phase is 0.4, then we multiply it by 2. And then all of those things we multiply by the total height, which is 8.6. 10.32 all in all. And then multiply that by the total number of columns, 8 times 10.32. You will have 82.56 square meters for the entire C1. Now let's go to the column ties. How do we estimate the quantity of the column ties? Let's first look at the spacing. We have 2 pieces at 50, 5 at 75, 6 at 100, and 200 for the rest of the spacing. So if we are going to tally it here, I will make use of this space here to tally all the spacings. So S1, say S1, S2, S3, S4, and then rest. 2 pieces at 50. That will be your S1. 2 pieces at 50. Let me just insert one more row to separate the spacings. Next is S2, 5 at 75. 5 at 75. Let me adjust the decimal place to avoid confusion. The next spacing is 6 at 100. 6 at 100. And the last spacing, there is no S4. We go directly to the rest of the spacing, which is 200. Okay? Now, how do we make of all of this? First, let's account for the standard spacings near the support. So, how many are all those spacings? We have 2 plus 5 plus 6, and then multiply it by 2 since there are 2 supports, times 2. Okay? So, we already have 26 ties near the support. And then for the rest, before we can compute the rest, we still have to add all of the spacings accumulated near the support. So if we add all the spacings, let me use this cell here, 2 times 50 plus 5 times 75 plus 6 times 100. No, sorry. We link it here. Plus this one, S4, times the lower part, which is here. Now, if that cell is empty, then it will not be included in the addition. So the rest, the total spacings near the support will have a total dimension of 1075. Let's multiply that by 2 because there are 2 supports in every column, times 2. So the total accumulated spacings near the supports is 2050. Okay? So for the rest, okay, so we can better count for the ties. Let's prepare a C1, separate in the ground floor, then separate in the second floor, as well as the roof level. No, so we can account for the spacing better. So instead of 8.6, I will use 1.2 plus 1 plus 3.2. And this C1 now is foundation to second floor. Okay, and then I will add another C1 for second floor to roof beam. So the total height now is 5.4. Okay, so to account for all of those ties, we have 5.4, which is the total height. Let's multiply that by 1000 to make it into millimeter, minus this value here. Okay, so you have 3250, and this 3250 will be divided by the rest. Okay, so 3250 divided by, let's put a parenthesis here, divided by 200. So there is 16.25 pieces. Okay? So let's add something to make the formula more accurate, which is to round up to the nearest ones, no, or to the nearest whole number. So round up 0. So it became 17 instead of 16 point something. So 17 ties. And then it is a good habit to always add 1 just for allowance purposes. So plus 1. So that will be 18 ties. Okay? And since I temporarily place it here, I will now copy this one. Copy. No, I click the formula bar and then copy. Control C. And then paste it in the rest. Okay? So you have 18 for the spacing at the rest. Yeah, the total spacing now will be 26, which is the sum of all of these spacings near the support plus 18. So you will have a total of 44 column ties. Okay? So 44 column ties equals 44. And then for ties number 2 still equals 44. Alright? For the ties 1, the length is here. No, this is the total length plus the hook. And yeah, the hook, which is 135 degrees. But as a rule of thumb in estimating, instead of calculating for the hook and then the spacing between the face of the column towards the outer part of the rebar, instead of doing that, as a shortcut, we will just measure the perimeter of the column. So the perimeter of the column is twice of its width, so 0.2 times 2 plus 0.4 times 2. So that is the length of column tie 1. And then for the column tie 2, this one here, no, this is just the width of the column and then a little bit of allowance for the hook. So let's say equals 0.2 plus, let's say 0.05 allowance for the hook, or 2 inches. So 0.025. Now the allowance will be subjective based on the assessment of the estimator. Now let's have the weight. We can just drag this formula here, as well as here we can drag this formula. With this formula we will just pinpoint it here and then go back to this quantity. We can pinpoint this formula and then go back to the quantity, because the quantity here is not dragged all the way down. Okay? So we are now done with the calculations for C1.